I'm here with Dr. Jim Garvin. Dr. Garvin, a couple of months ago, we talked to you prior to the Venus transit, and you gave us some great insight to that historical event and how important it was to the agency and to people here on Earth, period. Right now, we're here at the landing of the Mars Science Laboratory. How important is this individual event, and what is your involvement with the program?
So this landing, the landing of the Mars Science Lab rover called Curiosity, is momentous. First time in human history, in the history of women and men exploring our universe, our world, our own planet, we will be moving a surface observatory weighing a metric ton to go investigate aspects of Mars that are close and personal to us. Are there any of the forensic fingerprints, the traces of the chemistry that could have indicated Mars was habitable and even in the ancient past inhabited? This is asking, are we alone at the level of the rocks and the soils with the kind of lab gear that we typically have in institutions and big laboratories here on Earth? So we're going to be doing that on Mars. So I think in the annals of human history, this is a first. We've kept the people here to send the robots there. And for me personally, this is extremely deep and moving because 11 years ago, as part of the restructuring of the Mars program, I was the chief scientist for Mars exploration at that time. This was our culmination, the gateway to the future of how people and machines would explore this amazing world. Mars is the closest thing, we think, we're still learning, to a place that could have been an abode for life like Earth, at least early Mars. So if we don't figure out how Mars worked back then and relate it to our own planet, we really can't know our own history. So by going to Mars, we're reading sort of a time machine back into what was life like, if it existed, in these early billion years or so of the formation of our inner planets. And so Mars is the best place to go and ask those questions. And this vehicle, the Mars Science Laboratory rover Curiosity, its instruments, best equipped in the history of women and men to do that.
Well, you know, during the Apollo program, astronauts went to the moon, collected rocks, brought them back to Earth. They were analyzed on Earth. And what you're saying here through the MSL, those rocks and soil will be put inside of Curiosity, and those same tests done in place on Mars.
A generation ago, human beings, brave, courageous, in this case men, visited the moon for 2-day sorties and collected nearly 900 pounds of these priceless samples of the history of another world. And we brought them back to Earth, and we were revolutionized. Oh my God, the surface of the moon was an ancient record book 3 to 4+ billion years ago. Nothing like we normally see on Earth, anywhere you'd normally go. So, what we've now done with robots, with new technology, with smart engineers, computers, and scientists working together, we've said, okay, Mars is really hard to get to for people right now. We'd love to get them there. It's an aim, I think, of the space agencies of the world. So let's invert the question. Let's send the best lab gear, the kind we had in labs here on Earth in 1969, 70, 71, 72, to Mars. And so inside Curiosity, we have 2 payloads, one about the size of a microwave oven. That seems to be a unit of instrument size. But anyway, we all have them, so, which can measure parts per billion of the chemicals and the history of those chemicals that make up the rocks and soils that are, if you will, the fingerprints for past environments and even for past chemistries that could link to life if it ever existed. We'll be able to make definitive analyses, dozens of them, of the most interesting rocks and soils in ways so far beyond anything we've ever done in deep space that it's almost unimaginable. They will be as good as those we made when the first moon rocks came back here on Earth, now through robots with people here on the surface of Mars. We'll use techniques that a geologist like myself uses, normally with big instruments in our labs, to measure how the rocks put themselves together through what we call minerals. We'll be able to measure definitive mineralogies, how that rock was formed and how it lived and grew up to be what it is on the surface of Mars through an instrument that does what we call X-ray diffraction on Mars.
Before MSL can get on Mars and do all these great science experiments, it actually has to land. And you are instrumental in that part of the landing where you can actually see the surface before Curiosity lands.
So Curiosity has to go through a really tough transition from hitting the top of essentially the sensible atmosphere at 13,000 miles an hour and coming safely into the final tens of seconds before the sky crane drops this 1 metric ton vehicle of exploration on the surface. In the end game, in the last minute or so, we have a special system that will allow us to photograph in movie mode, high definition movie mode, the site where we will finally come to rest in our touchdown. This is new. This is revolutionary. This camera system, developed by Malin Space Science Systems in San Diego, can basically take every fifth of a second, a high-definition frame, and put them together as a movie, but also, especially when we get really close to the surface, produced images the size of maybe a backyard, a football field, at exquisite resolution. At the resolution as if we were standing there with ourselves.
I'm going to stop you right there.
Right.
You said images the size of a football field, so that when you push in and magnify, you're really looking at a really close.
Absolutely.
What are we talking about? Millimeters, centimeters? What kind of clarity will we have?
In the final phases, 10, 20, 30 feet above the ground, we'll be in the centimeters, less than an inch resolution of things that for we geologists, we forensic Mars scientists, will be able to discern things that will help inform how we work with Curiosity on the surface. Now, we've seen our landing site from the exquisite eyes and ears of the Mars Reconnaissance Orbiter now, through its big camera, the high-rise camera, at roughly 2 or 3 feet resolution now for the last several years. So we know what it's like at that scale. But at the fine scale, since we're doing a mission where we want to see how the rocks put themselves together, how they're layered, how they're distributed, these are the kind of fingerprints that tell us, how did the rocks get there? What formed them? How could they preserve the chemical evidence of the things we're looking for?
What does the science that the MSL is going to collect on Mars, what does it mean for the future of human space exploration?
By doing this kind of surface exploration, we are first paving the way for how human beings someday can explore that surface. We're even carrying an experiment to understand the radiation dosage that a person, a woman or man, or multiples, would experience if they were on Mars walking along with MSL, trotting along maybe. We're going to make those measurements. What we discover with MSL about the ability to discern records of habitable environments, ancient climate states that were really, really interesting for preserving evidence potentially of ancient life, or not, will dictate how we explore. One of the things we know definitively, MSL will inform how we choose to pick the materials we will need to return to Earth to study before people go. We want to bring back pieces of Mars. Mother Nature's delivered meteorites we believe came from Mars, but we don't know when and we don't know where. And those meteorites have been corrupted by traveling in space, unprotected, and crashing down to Earth and sitting in the Earth environment, which is, a very dynamic weathering environment. On Mars, we want to see what MSL tells us to help us select what do we need to bring back so we can pick apart the records of these ancient environments, these chemical pathways, as my boss likes to say, molecular fossils if they exist, to see whether in fact Mars was ever alive. If we understand that, that'll better allow us to engage humans someday in the distance. Hopefully the kids today will be that group to explore Mars firsthand, because I think that will be the visceral experience. MSL will give us a taste of that vicariously. But when we go ourselves, humanity, and stand and kick our boots, feet, whatever, probably not sandals, it's cold there, boots on Mars, that will be, like the Columbus voyages of the early Renaissance, looking at the new world where we're living. So to me, MSL is the pathfinder.